Okay. See now. So as I told you, the Schrodinger wave equation have number of solutions. Some of them are real and some of them are imaginary. The solutions which are imaginary, they doesn't have physical significance. The solutions which are imaginary, they doesn't have physical significance, but the solutions which are real, they have the physical significance. And as I told you, they have the physical significance. And what we find in the Schrodinger wave equation, काय काढलं आपण स्क्रोडिंजर वेव्ह इक्वेशन मध्ये काय काढलंय दोन्ही याच्यामध्ये बघा पहिल्या इक्वेशन मध्ये काय 8 पाय स्क्वेअर m अपॉन h क्रॉस स्क्वेअर किंवा h स्क्वेअर असेल 8 पाय स्क्वेअर बरोबर आहे n स्क्वेअर h स्क्वेअर आठवतंय बाकीचा e मायनस v इंटू साय वगैरे डेल स्क्वेअर साय बरोबर आहे का इक्वेशन स्क्रोडिंगर वेव इक्वेशन इन टाइम इंडिपेंडेंट फॉर्म म्हणतो इंडिपेंडेंट the term which does not depend on the time, the terms which does not depend on the time, and in that case what we consider तिथं बघा आपण पोटेन्शियल एनर्जी कायनेटिक एनर्जी कन्सिडर केलाय टोटल एनर्जी घेतली म्हणजेच एनर्जी डिपेंडंट घेतलेत आपण टाइम डिपेंडंट घेतलेला नाही the term which are energy dependent लक्षात येते का बघा e minus v is equal into psi घेतले आपण that is a kinetic energy and the particle when the particle is at its mean position बरोबर आहे का स्क्रोडिंगर वेव्ह इक्वेशन मध्ये आपण जे सोल्युशन देतोय that solution time independent म्हणतोय म्हणजे which does not depend on the time means which are where we are along the mean path or propagation axis. At that point only the kinetic energy is maximum and the potential energy is zero. But near to that mean part or the mean position, we are taking the solution. So that is time which in that case we are considering that solution is energy dependent solution. That is energy dependent E minus V. That gives you the kinetic energy, and that is a basic part of that solution, right? Okay. मग पुढचा पार्ट काय म्हणलाय the solutions which does not depend on time that are time independent and the solutions which are depend on the time that are called the time dependent solutions, right? Similar to that, out of them some are real imaginary. Those which are real they have the physical significance, and those are imaginary, they doesn't have the physical significance. As they doesn't have the physical significance, we does not bother about that solutions. We only consider that the solutions which are real. So for the real only we are considering here, and the energy value of that the solutions which are real, the solutions which are real means particles are there and that particles have the energy and that energy is called energy eigen value. The particle have the energy and with that energy the particles are vibrate or propagate, and that energy already we find that energy kinetic energy kinetic energy is equal to E minus V into psi E minus V, that is a potential total energy minus potential energy केलेले इक्वेशन एक वेळेस लिहायला लागते का बघा आठवतंय का इक्वेशन आठवतंय का बघा हां सांगू शकताय काय इक्वेशन आहे that is a del square psi plus 8 pi square बरोबर आहे 8 pi square upon h square 8 pi square m upon h square into E minus V into psi is equal to 0. Okay, this is the Schrodinger time independent wave equation. In this case, depend on the time. मग इथं मात्र काय घेतलं ही एनर्जी टर्म आहे and it is depend on the energy. Okay. Now see in this equation. मग आता ह्या इक्वेशन वरून मी काय म्हणलंय in this equation आता याला जे सोल्युशन दिलं आपण this is a solution. This is a real solution. It has the physical significance. It has the physical significance means this energy is called energy eigen value or eigen value. This energy is called eigen value. And next आता ही ज्या पार्टिकलची एनर्जी कन्सिडर केली आहे मी ज्या पार्टिकलची एनर्जी कन्सिडर केली आहे इफ आय कन्सिडर दॅट द पार्टिकल इज रियल मीन्स सोल्युशन इज रियल लक्षात येतंय बघा द सोल्युशन इज रियल इट हॅज द फिजिकल सिग्निफिकन्स स्टेप वाइज लक्षात घ्या द पार्टिकल इज रियल इट हॅज द इफ पार्टिकल इज रियल इट हॅज physical significance. If it has physical significance, the solutions which have the physical significance only we have to select, right? And the energy of that particular particle is called energy eigen value. Okay, let's suppose to be that particle is to be vibrate and generate the wave. And in that wave, my particle is somewhere. So that psi gives the position of the particle in the wave. So that psi is called eigen function. Means for a particular energy, we are not talking about the time. मागच्या केस मध्ये आपण काय म्हणतो तो in the time instant t in my particle is here. Let's suppose to be if I have to draw this waveform in time instant t my particle is here, so in time instant t dash it will be here. In time instant t, let's suppose to be the particle is at here, then next case in time t dash my particle will be here. It means the position is different, right? But one thing is known to you that energy of the particle is constant everywhere. Average energy is always constant. We know that. Average energy is always constant. If I have to take the kinetic energy, then kinetic energy, my potential energy is 0 near to this propagation axis. My potential energy is 0. Then kinetic energy is equal to total energy at this point. And at this point, the kinetic energy is equal to potential energy is equal to total energy. So the kinetic energy at here is 0. So point to point it will be get changed, right? So the kinetic energy and potential energy त्याच्यावरतीच पुन्हा सांगतो मग एनर्जी आयगन व्हॅल्यू कळाली जी काही व्हॅल्यू ऑफ द एनर्जी असेल या पार्टिकलला असणारी एनर्जी किती आहे मग दिस इज द एनर्जी या पार्टिकलला असणारी एनर्जी E minus V. And this energy is called eigen value, energy eigen value, and the corresponding wave function for that particular value of energy is called eigen function. And this is the eigen value and eigen function. आता बाकीचा एक्सप्लेनेशनचा पार्ट आहे. हे बेसिक जे आहे बेसिक सांगितलेलं आहे मी बघा झालं इथपर्यंत आलं लक्षात ओके देन this and eigenvalue याला आता थोडंसं एक्सप्लेन करून सांगते बघा काय केलेलं आहे. As eigen function has physical significance, if I said that it has the physical significance, then it satisfies certain conditions, and that are they have only one finite value which is continuous and real. They have only one finite value which is continuous and real. So the Schrodinger interpreted that this function in terms of charge density. This function means this wave function psi is in the form of charge density. And how we have to find the charge density? That wave function psi mod of psi square gives the probability density of finding the particle. That already we know that. And if I have the density of the state or the density, then if I have to multiply it with the charge of the particle, then I got the charge density. जर मी त्या असणाऱ्या माझ्याकडे जी असणारी डेन्सिटी आहे, डेन्सिटी म्हणजे काय, मग आधी डेन्सिटी काय असते, डेन्सिटी म्हणजे काय, मास पर युनिट व्हॉल्यूम, बरोबर आहे का. अँड इन दिस केस आता इथे डेन्सिटी काय माझी, नंबर ऑफ पार्टिकल्स पर युनिट व्हॉल्यूम, number of particles per unit volume. In any electromagnetic system, the energy density or charge density, आता energy density चा काय concept आहे आणि charge density चा, मला वाटतं मी charge density सांगितले. Charge, if I have to multiply the probability density by charge of the particle, then it gives a charge density, and particular particle have its own energy. So if I have to add one more particle, then energy is also goes to increase. Energy goes on increasing and density is also increased. Means number of particles in that unit volume, in a given volume, that gives you the energy density or charge density. So this energy density is equal to, it is proportional to a square. आता what is the a square? A is the amplitude of the wave. जेवढे जास्त पार्टिकल असतील किंवा जेवढे पार्टिकल जास्त एनर्जी असेल, बघा बरोबर आहे का, जेवढी जास्त एनर्जी असेल पार्टिकलला तेवढा तो पार्टिकल काय करेल, विथ मॅक्सिमम एनर्जी इट विल बी व्हायब्रेट. समजा हाय एनर्जी पार्टिकल असेल असा व्हायब्रेट होईल, थोडीशी एनर्जी कमी असेल, that particle will vibrate like this and it form the small wave. जसं एनर्जी जास्त मिळेल तसं तो त्याचा amplitude वाढत जाईल, right? So this amplitude is directly proportional to energy. जेवढी जास्त एनर्जी तेवढा जास्त त्याचा amplitude असेल. That thing very clear. Again we know that if I have to talk about this about the electron, then energy density is equal to amplitude square. Or it is nothing but the, simply I have to write this is I is proportional to a square. That means the intensity. माहित आहे आपल्याला intensity. What is that intensity? Intensity जेवढा हे amplitude जास्त असेल तेवढा intensity जास्त असेल, बरोबर आहे, झाले आपल्याला हे, ठीक आहे. Then I is proportional to a square or energy density is proportional to a square. Then the number of photons per unit is equal to the energy density divided by energy of the photon. That means काय काढायचं मला इथं, सिंपल हे बघा, डेन्सिटीचा फॉर्म्युला काय आहे, मास अपॉन व्हॉल्यूम और नंबर ऑफ पार्टिकल्स टू द व्हॉल्यूम. इट इज नथिंग बट नंबर ऑफ पार्टिकल्स to the volume, right? That is nothing but density. If I have to write it by the rho, number of particles is equal to number of particles is equal to simply rearrange it. Kyle, on rearranging it, number of particles is equal to density into volume, right? Rho into volume. Or simply, if I have to write this number of particles or the photons is equal to density or the energy density. It is energy density upon energy of a single photon, that is h. Energy of the photon h nu. Okay, but we know again the photon density is, again for the photon, it is photon density is energy density upon photon density is equal to energy density upon h nu. So we can write it as a square upon h nu, and this is the photon density. Okay, similarly मग काय असेल, that means a square upon h nu, energy density upon h nu is nothing but energy density upon h nu is nothing but a square upon h nu, right? As h nu is constant, means the energy of the photon is constant, and that is already we know. The energy of the photon is always constant. Okay, then next, similarly, this psi or the wave function psi is amplitude of the matter wave at any point in space. बरोबर आहे का? इक्वेशन लिहिते वेळेस काय लिहिले आपण? psi is equal to psi 0 of x y z t or r t लिहिलं असेल. Psi 0 of r t. What it indicate? This psi 0 is the amplitude, right? आणि psi काय कन्सिडर केला त्या केस मध्ये? मग psi is a wave function, but it is nothing but the amplitude of that matter. Psi 0 into r of t, that is r is a coordinate x, y, z, and in time t, its amplitude means the amplitude of that wave in time t. Amplitude of the wave in time t, that gives psi is equal to psi 0 x, y, z, t. Similar to that, मग मी काय म्हणलं, psi is the amplitude of the matter wave at any point in space. So the particle density, this particle density, आता particle density काय असेल माझी? मग particle density is proportional to, instead of a, it now it proportional to mod of psi square, right? And this mod of psi square is the particle density. Mod of psi square, this particle density is proportional to mod of psi square, and this mod of psi square is nothing but the particle density. And if we have to multiply it by charge of the particle, then we get the charge density. ओके, कळतं इथपर्यंत? सिंपल आहे. मी ते जे सुरुवातीला सांगितलं तेच रिपीट झालं, काही नाही याच्यामध्ये. आता इथून थोडासा पुढचा पार्ट लक्षात घ्या. This was interpreted by the Schrodinger. काय की mod of psi square is a particle density. It is proportional to particle density. Then after that, this interpretation gives the satisfactory result when wave mechanics applied to the stable state. When we have to apply this to the stable state, but it does not give the satisfactory result when we have to apply it to the moving states. Stable state, immovable, but when that your state is in the moving position, then this result or this interpretation does not match or does not satisfy. Right? And this mod of psi square is a particle density. It is proportional to particle density. Then after that, this interpretation gives the satisfactory result when wave mechanics applied to the stable state. When we have to apply this to the moving states. Stable state, immovable, but when that your state is in the moving position, then this result or this interpretation does not match or does not satisfy. So later on, certain difficulties are arises, and the difficulties are solved by Max Born. The difficulties are solved by Max Born, Heisenberg, Bohr, and they put forward the interpretation of psi according to the mod of psi square. According to them, mod of psi square does not measure the particle density or charge density. It gives only probability density of finding the particle in that system. So that probability P is, so the probability P is equal to psi of x, y, z, psi of x, y, z, and the probability density means the psi star of x, y, z, where psi and psi star are complex conjugate of each other. Psi and psi star are complex conjugate of each other. Okay, right. Now next, this psi is value of the psi is equal to, we know that, a plus ib. It means that this wave function is imaginary. Next to it, again one thing is known to you, that what the probability P has, this probability P has value, probability, maximum probability किती हो 1 and minimum probability 0. It means that probability has the value greater than or equal to 0, less than or equal to 1. But the probability has a greater value, smaller value, or it has the 0 value, but it doesn't have the negative value. Negative probability has 0 meaning. Negative probability does not have any meaning. That already we seen. Negative probability. Negative probability possible? No. There is no possibility of negative probability. So the probability has the value in between 0 to 1. Right? Okay. And if psi is real, then if psi is real, the probability 1 असेल माझी, it means that particle is to be existing there. If probability is 1, my particle is existing in my system 100%. मी मला वाटतं सांगितलं बरेच वेळेस. 1 character and 0 means does not exist within the system. That particle does not exist within the system. So if I have to consider that the particle is to be exist in the system, so psi is real. Psi is real. And if psi is real, then what about the psi star? Psi is a real असेल, it means that this a plus ib च्या जागी काय असेल हा a plus b. So what is the psi star? If psi is equal to a plus b, then what is psi star? हाँ कौन सांगते हैं? माइक अनम्यूट करू शकताय, सांगू शकताय. बरं ठीक आहे, एक मिनिट बघा. If psi is a plus ib, then my psi star is a minus ib. If हाँ yes, बरोबर आहे. If psi is equal to a plus b, if psi is equal to a plus b, then what is psi star? त्याचा कॉम्प्लेक्स कॉन्जुगेट काय असेल? a minus b. It is a minus b. बरोबर आहे. ठीक आहे, बघा इथे जर a plus ib असेल तर मी काय घेतलंय a minus ib. ओके, कॉम्प्लेक्स कॉन्जुगेट करते वेळेस काय करायचंय म्हणलंय? psi changes to psi star and I changes to minus. Does not change more than this. We can't change more than this. फक्त काय करतो, I ला minus I करतो, psi ला साई स्टार करतो. एवढंच करतो का नाही बघा, कॉम्प्लेक्स कॉन्जुगेट करते. We can't change more than this. Okay, then next. मग I चा मायनस I होत आहे. आणि जर I नसेल तर, if my function is real, that is a plus b, then the complex conjugate of that real function is as it is. It means that yes, it means that psi is equal to psi star. And if psi is equal to psi star, then what about this mod of psi square? Mod of psi square is equal to psi square. बरोबर आहे ना? If psi is equal to psi star, but mod of psi square काय आहे? Mod of psi square is nothing but psi into psi star. आता हा psi star आणि psi same असतील, then it becomes psi square. So I have psi square is equal to psi square. Right? Okay. Then after that, पुढचा बघा मग आता. Again, I think already we seen that this wave function satisfy certain conditions, and मला वाटतं त्या conditions wave functionच्या conditions बघितलेत आपण. कुठल्या? It can be normalized. आठवतंय का बघा? Wave function can be normalized. झालेली आहे. It can be normalized. हा पुढे त्याच्यानंतर it has a single valued. It can be real and positive, finite. बरोबर आहे? It is finite at a single point. At that point, it has the finite and real value. So that conditions just we have to revise again here. It must be single valued at each and every point. This wave function, we conclude that this wave function psi must satisfy certain following conditions. If psi is equal to psi star, then it can be satisfy some conditions. It means that it is, जर तो real असेल तर मग काय म्हणले मी, it must be single valued at each point. Real असेल तर मग काय, प्रत्येक पॉइंटला त्याची व्हॅल्यू बदलते. It is a single value at each point. Then it must be finite and real at every point. प्रत्येक पॉइंटला त्याची व्हॅल्यू finite असेल. Means if my particle is at this point, its value is, let's suppose to be x, y, z. Then at this point, its values are x dash, comma, y dash, comma, z dash, and time t dash. Here in time t. बरोबर आहे? म्हणजे इथं टाइम तुमचा चेंज असेल, त्या ठिकाणी तुमचे कोऑर्डिनेट सुद्धा चेंज असतील. That means again at this particular time t dash, it has the finite value. And these values are finite and real. Okay, its absolute value at all point must be such that its absolute value at all point must be, आता ह्याची absolute value काय? ट्रिपल इंटिग्रल मायनस इन्फिनिटी टू प्लस इन्फिनिटी minus infinity to plus infinity psi of x comma y comma z into psi star of x comma y comma z is equal to, आणि हे ट्रिपल इंटिग्रेशन घेतल्या म्हणून dx dy dz it is equal to psi किंवा psi star into psi integral over psi star into psi into d2. तर हा पर्टिक्युलर हे जे नोटेशन आहे, it is about the tau, आणि इथे tau साठी घेतलाय that d2. tau means मी काय घेतलाय, d tau is equal to dx dy and dz. काय म्हणायचं याला, टो हे पर्टिक्युलर नोटेशन आहे, रिलॅक्सेशन टाइम साठी आहे. तुमच्यासाठी इथे नाही त्याचं काम, पण इथे लक्षात ठेवा, ऑल माझे जे ऑल कोऑर्डिनेट्स आहेत, दॅट ऑल कोऑर्डिनेट्स इन्क्लूड इन दिस टो, दे आर इन्क्लूड इन दिस 2. So I have written here d2 dx dy dz. In combining to all, we get d2, and as we said that the wave function is normalized, means this psi star psi into d2 is equal to 1, and this is the wave function, and this is eigen function. This is eigen function. Eigen value वर सांगितले मी eigen value तुम्हाला. What is that eigen value? Energy value. Energy ज्या ठिकाणी काढली त्या ठिकाणी energy ची value सांगितले, energy density सांगितले, eigen value सांगितले, and this is the function eigen function, where tau is the general symbol for all the coordinates. This tau is a general symbol for all coordinates. As there is electron in given system, the probability is 1, or if there is a particle in a system, then probability is 1. Okay, this is about the eigen value and eigen function. अच्छा, इथं काही मला वाटतं की डाऊट असेल, काही प्रॉब्लेम असेल विचारू शकताय. आणि हा थेरॉटिकल पार्ट आहे. मी जरी बरेच इक्वेशन लिहिले असतील तर तुमच्याकडे नोट्स पाठवलेले आहेत मी होते, त्या नोट्स मध्ये तुम्हाला एवढे इक्वेशन दिसणार नाही, निश्चित दिसणार नाही. माहिती असावी, कळावं एवढ्यासाठी मी इक्वेशन जास्त लिहिलेत, पण एवढे इक्वेशन्स तिथं नाहीत, त्यामुळं फार मोठे इक्वेशन दिसतायत वगैरे नाही. जस्ट रीड आउट करा, लक्षात येऊन जाईल काय आहे.